Okay, Assalamualaikum warahmatullahi wabarakatuh. So welcome to EECE 2318. So today we're going to enter chapter 3 Vector Analysis. So these are the keywords for today. We're going to learn on scalar and vector, unit vector, position and distance vector, dot product and cross products. Now, what is scalar and what is vector? A scalar is a quantity that only have magnitude, which is represented by a single real number. So the examples of scalar are speed, energy, temperature, voltage, and current. So notice that all these examples doesn't have any direction. Vector, on the other hand, is a quantity represented by both magnitude and direction. So the examples of vectors are velocity, force, and electric field. A vector A has a magnitude of A in the borderline. So when you see a borderline like this, that would be the magnitude. And a direction specified by a unit vector. So if you have A, so it is denoted with a small letter A with a hat. That is a unit vector. So unit vector A has a magnitude of unity. A vector whose length is 1 is used to signify the direction, noted with small bold letters with hats. For example, if you have vector A, so the unit vectors would be a small a bold with a hat. Vectors are expressed in terms of the standard base vectors. So usually we will use x, y, z. Okay, so all of these are denoted by small bold letters with a hat on top. So x hat is the unit vector for direction of positive x. Y hat is the unit vector for the direction of positive y. And z hat is the unit vector for the direction of positive z. For example, if you have vector A, okay, vector A, that would be equal to ax x hat plus ay y hat plus az z hat. So the one that is in small bold letters with a hat on top, the red ones here, that is actually the base vector, the unit vector. And then the one that is denoted by the ax, ay, az, these green letters here are actually the displacement. They are the scalar quantities. Now, how do you find out what the magnitude of the vector is? So how do you calculate? That would be the magnitude of the vector A. So the one A in borderline is equals to the square root of ax squared plus ay squared plus az squared. So all these three is actually the displacement or the scalar quantities. Next, how to find out the unit vector, which is a hat. So a hat is equal to vector A divided by the magnitude. So that would be ax x hat plus ay y hat plus az z hat divided by the square root of ax squared plus ay squared plus az squared, which is the one on top here, the magnitude. Now, when you have two vectors, okay, for example, you have vector A and also vector B. So how do you know that AB is equal? Provided that if and only if your AX is equal to BX, your AY is equal to your BY, and your AZ is equal to your BZ. So you have to make sure that all these three is the same for A and B to be equal. Vectors addition and subtraction. So when you have two vectors A and B and you want to add them together, that would be adding up the scalar quantities. So you have AX plus BX times with X hat plus AY plus BY times with Y hat plus AZ plus BZ times with Z hat. For the subtraction, okay, when you have vector A minus vector B, so you have to minus the scalar quantities. So that would be AX minus BX X hat plus AY minus BY Y hat plus AZ minus BZ Z hat. What does it mean by position vector? Position vector is an alternative way for you to describe the position of a point in the space. Take for example position vector P of some point. So you will have P x1, y1, z1, which is the vector from the origin to that point. Okay, which is point P. So in terms of base vectors, we would have P is equal to x1, x hat, plus y1, y hat, plus z1, z hat. So P is the quantization of the position of P with respect to some reference point, which is the origin of the coordinate system. And then P in the borderline is the distance from the origin to P, and P hat is the unit vector in the direction from the origin to P. Distance vector or separation vector is a description of the distance between 2 points. So now instead of having only P1, you have P2. Okay, so distance vector P12, okay, of 2 points. This is not P12, yeah, it is P12. Okay, so you will have 2 points, P1 and also P2, which is the vector representing the distance from P1 to P2. So how do you relate between these two? So you can calculate the position vectors P1 and P2 by subtracting P2 minus P1. Okay, so you have P1 is equal to P2 minus P1, which means that the x2 minus x1 times with x hat times with the unit vector, don't forget that, plus y2 minus y1 times with the y hat, the unit vector, plus z2 minus z1 times with z hat. So in this case, P12 is a quantization of the position of P2 with respect to P1. Okay, always read it from the right hand side to the left hand side. Okay, so P12 in the borderline here is the distance between P1 and P2. Okay, P12 hat is the unit vector in the direction of the line which is connecting the P1 and P2. Now, multiplication by a scalar. So CA, okay, when you want to multiply with C, so you have a vector A, you want to multiply with C. So vector A is AX X hat plus AY Y hat plus AZ Z hat. So when you want to multiply with C, that would be CAX X hat plus CAY Y hat plus CAZ Z hat. So usually when you talk about scalar product and vector product, that is actually referring to dot product and cross product. Now let us look into dot product. So dot product can also be called as scalar product or inner product. Okay, why does the dot product is called as scalar product? It is because the result is a scalar. So for any two vectors A and B, okay, the dot product A dot B is defined as AX BX plus AY BY plus AZ BZ. Notice this is scalar without any unit vector involved. So properties of the dot product A dot A is actually A squared. Okay, A dot B is equal as B dot A. A dot B plus C is equal to A dot B plus A dot C. And C times with A dot B is equal to A dot B or A dot CB. Now in terms of A and B, the magnitude that will be A dot B is equal to the magnitude of A and B cos theta. So theta is the angle between A and B. So the dot product gives the effective value scalar of the two vectors. So you're going to have A dot B is equal to the magnitude of A and B cos theta AB. For example, if you see these two vectors here, you have a vector summer and vector winter. So vector summer has its own theta, which is theta 1, and vector winter has its own theta, which is equal to theta 2. Next, we have cross product, or we can call it as vector product. So when you have two vectors, vector A and vector B, the cross product of A and B is defined as this matrix here. So you're going to have x hat, y hat, and z hat, ax, ay, az, and finally bx, by, bz. The resultant vector is orthogonal to both vector A and vector B. And the direction of A cross B is given by the right-hand rule. Now, in terms of magnitude A and magnitude B, okay, so you have the magnitude of A cross B is equal to magnitude A, magnitude B, sine theta. Okay, so the difference here is in the term of sine theta. So theta is the angle between A and B. Hence, sin theta is equal to A cross B over A times with B, the magnitudes. So A and B are parallel only if and only A cross B is equal to 0. Now, the cross product of two vectors is about rotation in the plane, which is defined by those two vectors. So when you have A cross B, which is equal to AB sin theta, like the one that we have seen before, that actually means the rotation on the plane. So you have the cross product. So you have A here showing, and then B, which is perpendicular. So A cross B is actually, so the direction of AB is using the right-hand rule. So you have A and B, which is perpendicular. So the cross product is actually over here, the A cross B. So the cross product of these two vectors is about rotation in the plane, and you will get A cross B, which is here.